I'll just be introduce you to the aspect of binary operations. This is very interesting. I'm sure you've heard of it. And so I'll try to make it as simple as possible within the series of about 4 videos. So what exactly is a binary operation? So if you look at the term binary itself, binary means two. Okay, so a binary operation involves aspect of you performing an operation on two digits, numbers. Okay, so for example, 2 plus 4, it's a binary operation because of what? Two things. So all the things we know, subtraction, multiplication, division, they are binary operations because they only they can only be performed on two things at a time. Okay. Now, when you look at the definition of a binary operation, what a binary operation is defined on a given set is the fact that let's consider a set 0 and 1. Okay, so it is only a binary operations. Let's call this set to be S. Addition can only be said to be a binary operation on the set S if and only if all operations you can perform on that set, the result is going to be within the set. So let's try out that. So we're trying out addition. 0 plus 1 is 1. So you only perform on two different things. Don't say, no, I'm going to add one with itself. No, only two different things. So in this case, we are saying that there is only one binary operation you can perform, and the result is within the set itself. So we can conclude to say addition is a binary operation on the given set S. Okay? So that's what basically a binary operation is. Of course, we can disqualify the others. If you try multiplication in this case, 0 times 1 is a 0. A 0 is within the set, so even multiplication is a binary operation on that given set. Think of division. So division is actually never going to be a binary operation in this set. So how? So you have 0 and 1. 0 divided by 1 is 0. Quite alright, it's within the set. Now think of impossibilities. What if I said 1 divided by 0? That is undefined, right? So even if there is one that is saying yes, provided there is one that is going to disagree, then it is not a binary operation. That's what you need to understand. Now, to just ensure that you've understood deeper, I can give you another example where we can have 0, 1, and 2 as our set. Now, they ask you again to test addition, multiplication, subtraction, and division. So, of course, you know some of these are directly not binary operations. So division, of course, will not work. Why? Because I know if I try 1 divided by 2, it is already a 0.5, which is not part of a set. So division is not a binary operation. Subtraction, what if I said 1 minus 2? It is a negative 1, which is not in the set. Of course, 2 minus 1 is correct, but think of things that are going to disqualify it. Now, let's begin with addition. Do you think there is a binary operation that you can perform there that can give you a result outside the set? Clearly, I can say that if I add 1 plus 2, my answer is a 3. Now, is 3 within the set? It is not. So, even addition in this case is not a binary operation on the given set. How about multiplication? Can you think of any two numbers within the set that you can multiply that can give you a result outside that set? I don't think so. 0 times 1 is a 0, which is within the set. And then 1 times 2 is also a 2, which is within the set. 0 times 2 is also 0 within the set. So all the binary operations you can perform there, they are basically going to give you the result within the set. So multiplication is a binary operation on that set. I think that is now the basic introduction to binary operations. So let's proceed in the next video, where I now introduce you to the notation that we basically get to work with. So one of the things that you're going to be very familiar with under binary operations, in most of the questions they like using asterisk, or they can also use this symbol. So it doesn't matter which symbol they use. Okay. So now addition, subtraction, multiplication, those are also some of the questions you can have, but the most kind of questions you may have are these ones. Okay. So let's say they tell you to say x, and then they put a star there, asterisk. I don't know how you call it. Yeah. So x star y is equal to x squared plus y squared. Okay. So there are things like, is it a binary operation on a set of maybe integers and whatnot? So how would you look at this? So the way you get to look at these questions is it true that, remember from what we talked about in the previous video, we said the result would be within the set. Okay. So if you look at this, for it to be a binary operation on a set of integers, we understand what integers are. -1, 0, 1. So going this side and going this side. Those are integers. So now, is it true that if you basically use integers, you're going to get a result as an integer? Of course, I needed to show you how we basically get to perform a binary operation. So let's assume first of all we've given you 2 star 3. They ask you to find that. How do you basically find that? So the way it is you basically get them as they are matching up, right? That's the way you're going to handle it. So you say my x is 2, clearly 2. So you say 2 squared, and then where there's y, I'll put 3. That's the way it works as a binary operation. Simple and straightforward, right? Now it becomes interesting when you have more than 2. You have 2 star 3, and then again you have star 4. How do you handle this one? So BODMAS tells us to always begin with what is in the brackets. So I'll start with 2 star 3, which I know if I compare it against my x and y, my x is matching up with 2, my y is matching up with 3. So the same operation, 2 squared, I'm following what is on the right hand side. So to make it more interesting, we can change the y there. Let's say we had 2y, for example. That would mean where there is y, I'm now putting, maybe let me even say 4y, right? So I'll say 4. Where there's y, I'm putting a 3, because 3 is matching up with the y. So what will be our result there? We've got 2 squared, which is a 4. 4 plus 12, 16. So you have your 16. On your next step now, in the brackets, you're going to put 16. And then with what is outside, 4. Again, you compare it against the binary operation, which is x. X now match up with 16, and then the y will match up with 4. You do the same. X squared, so 16 squared plus 4 times 4. 16 squared, of course, I don't know. Yeah, of course you can simplify all that until you get your result. So I'm sure you've seen basically how we get to handle a binary operation. Now, I was asking a question to say, if you've been given x star y, so of course a symbol there doesn't matter. We can even put a symbol like that. The meaning is still the same. So let's say you have x squared and then you have 2y. They ask you to say, is this a binary operation on the set of integers? So what it means is it true that if x and y are integers, even your result is going to be an integer? So we've tried some of the examples, we've seen that you get the same, right? So ask yourself, x squared, Is it true that if you square an integer, the answer will still be an integer? It is true. Is it true that if you multiply any integer by 2, it will still be an integer? It is true. Is it true that if you add integers, you also get? It is true. So in this case, you can clearly see to say the square of an integer is an integer. Multiplication of an integer is also an integer. Addition of integers gives you integers. So this is a binary operation on a set of integers, because whatever integers you're going to plug in there, looking at the operations on the right hand side, there is addition and multiplication. So all those are binary operations. So it will be able you'll be able to maintain integers. Okay. So that's basically how you can handle such questions. Now, in addition to that, in the next video, now be exposed to questions that would require you to deal with associativeness and also the idea of commutativeness of a binary operation. So I hope you watch that video and get to understand more in details. I've got 4 questions that I want us to look at. So question 1. Determine whether a binary operation star is commutative on the following. So what we have is we have a star b being equivalent to ab minus a minus b squared. Okay, so I'll start with by evaluating first of all. So what we've been given is we've been given 3 star negative 1 star 2. Okay, so just like BODMAS gauges, we're supposed to start with what is in the brackets. So I'll get what is in the brackets. It's negative 1 star 2. Then I'll substitute in the equation corresponding. Okay, so for A it is negative 1, for B it's 2. So where we have A there, what are we going to have? So where we have A there, we're going to put now negative 1. Our B will put 2 minus. In the brackets we have A minus B. Our A is negative 1 and our B is 2. So it's going to be negative 1 minus 2 squared. So this is going to be negative 2. Then in the brackets we have negative 1 minus 2, which is going to be negative 3. Negative 3 squared is going to give us 9. So I have negative 2 minus 9, which is going to be negative 11. So what is in the brackets is giving us what? It's giving us negative 11. So we can now continue by substituting first of all. Again. So what is in the brackets is going to be denoted by negative 11. Then we can determine a binary operation. So binary operation means only 2 things are involved. So you can't solve it at a go. It's step by step. So we now have 3 star negative 11 equal to. So where is our A is 3. Then our B is negative 11. So minus. In the brackets we have A minus B. In this case our A is 3. So we have 3 minus negative 11. This is supposed to be squared. So 3 by negative 11, we have negative 33. Then in the brackets we have minus. 3 minus negative 11 is going to be 14. So 14 to the power 2. So when you get your calculator, or actually no need of a calculator, 14 by 14 we know it's 296. So we have negative 53 minus 296. So we have the same sign there, so we can add. So we're trying to add 296 plus what? Plus 53. So that is going to be a 9. 9 plus 3 is 12. Carry 1. So we have 329. So our answer is negative 329 after evaluating that. Okay, let's move on now. Let's try to show whether it is commutative or not. So what does it mean when we say commutative? So a very good example is when we say addition is commutative. So it doesn't matter which one you start with. So if you say A plus B is actually equivalent to B plus A, it means that it is what? It is commutative. So when you're talking about binary operations, you're proving whether it is commutative. You need to say, okay, since we have been given A star B there, how about if I say B star A? Are we going to have the same result? So if we can have the same result, then it means that the binary operation is what? Is commutative. So this is going to be. So again, we are going to substitute just away with potence. So we know that A is corresponding to the first A there. So if this is going to be BA minus, so where we have A, we are going to put B because we've started with B in this equation. So we have B minus A squared. So we can try to expand. So we know this part is going to be equivalent to AB because multiplication is commutative. So we can write it. Now let's try to expand. We see what we're going to get there in the brackets. So what is going to be B squared minus 2AB plus A squared. Okay. So that's what we have. You can write it again. AB minus, so I'll start with A. So we have A squared plus B squared minus 2AB. So this is corresponding to B star A. So how about if you try to expand our A star B? What is it going to give us? So our A star B, so AB is going to be maintained. Then if you expand what you have there in the brackets, so you're going to have A squared plus B squared minus 2AB. So how do we expand, in case you're wondering how we expand? So you say A minus B, again A minus B, then you begin multiplying. So A times A, it's A squared. A times negative B is going to be minus AB. Then negative B by A is going to be minus AB. Then B times B is going to be plus B squared. So this part is what is giving us minus 2AB in both situations. Okay. So are these guys the same or they're different? So if you look at the first one, it's A squared plus B squared minus 2AB. Even the last one is the same. This part is also the same. So we can therefore make a conclusion to say, since A star B is equivalent to B star A, the binary operation is what? Is commutative in this case. We're on the second question now. Okay. So we have A star B being equal to AB minus A plus B. So we're trying to determine whether a binary operation is commutative. So first of all, let's start by evaluating what we've been given. So we have 2 star 3 star 4. So we always start with what is in the brackets. So we have 3 star 4. So 3 is corresponding to our A, and our 4 is corresponding to B. So we have AB. So our AB is going to be 3 times 4 minus. The next part we have in the brackets, we have A plus B. So our A is 3, our B is 4. So we have 3 plus 4. This is going to be 12. 3 by 4 is 12 minus 3 plus 4 in the brackets is going to give us a 7. 12 minus 7 is going to be what? So how many? So how much should you add to 7 to give you 12? So it's 3 plus 2, 5. So the difference is 5. So we found what is in the brackets to be 5. We can now find the next part. So we are going to have now 2 star 5, the next step. So the 5 has represented everything in the brackets because that is the result that we are getting. So again, we'll go back to our equation. It's A times B. Our A in this case is 2 and our B is 5. So we're going to have 2 multiplied by 5 minus, in the brackets we have A plus B. So our A is 2 and our B is 5. So we have 10. 2 times 5 is 10. Then in the brackets we have 2 plus 5, which is 7. So 10 minus 7 is 3. So we've evaluated that. Okay. Let's try to move on now and show whether it is commutative or not. So from our first question, we are saying that if A star B is equivalent to B star A, then we can say that the binary operation is commutative. So we've seen that our A star B has already been given. Let's try to show our B star A. So B star A is going to come out the same way. So the first part is A times B. So this time around it's going to be B times A, but it's the same. So I'll just say A B minus. In the brackets we have A plus B. So here is B plus A. So b plus a is the same as a plus b. Okay. This part I can even show it the way it is. So ba is equivalent to ab. Then a plus b is also equivalent to b plus a. So these are the same. Okay. So you can therefore say the binary operation is commutative in this case. Question 3. Determine whether the binary operation star is commutative and associative in the following case. Okay. So without wasting much of our time, A star B must be equivalent to B star A if a binary operation is commutative. Okay. So now in this case we are also asked to show whether it is associative. So let's start with the commutative. So we've talked about it in the first two questions. You can pause the video and try it out. Okay. So our A star B has been given. So how about our B star A? So it's going to be, where is A minus B, it's going to be B minus A, because we started with B squared minus, so where is AB is going to be BA. Okay. So this part is actually the same. 2BA is the same as 2AB because multiplication is commutative. How about what's in the brackets? If you expand what's on top here, it's going to be A squared. So is it true that A minus B squared is equal to B minus A squared? So we showed this in the first question and it turned out to be true. Because if you expand this part, you're going to have A squared plus B squared minus 2AB. Within this part, it will be A squared plus B squared minus 2AB. So since these guys are the same, what can we say? We can say, okay, since A star B is equal to that, the binary operation is what? Is commutative. In a case where you get something else, it's not commutative. Now, how do we show that it is associative? Okay. So there are cases where I've talked about addition being associative, because if you say 2 plus maybe 3 plus 4, this is supposed to be equivalent to 2 plus 3, then plus 4. Okay. So what do we have there? So we have 2, then we have plus 7, then there we have 6. Is it 6? It's 5 plus 4. So this is going to be, it is going to be 9, that is going to be 9. So what is an example when you say it is associative? Okay. So in this case, we're going to work with it in terms of the letters, or actually numbers as well, to see what we're going to. So we can say, okay, how about if you say we have 2, then star, then in the brackets 3 star 1, for example. So if it's associative, this is supposed to be equivalent to 2 star 3, then star 1. So in short, what you're trying to say is whether you start with 2 and 3 or 3 and 1, then it's supposed to be the same. That is what actually what it means when it's associative. So whether you start by adding with this one, you go to the other one, it will still be the same. So it doesn't matter which one you start with when you say it is associative. So I want to prove that. So I'll start with the first part. So when you say 2 star 2 with what is in the brackets here, what it means is you start with what is in the brackets. So I'll start with 3 star. So we have 2. So let me start with 3 star 1. So 3 star 1, our A becomes 3. So if I go to the brackets here, I'm going to have 3 minus 1 squared. Then where we have AB is going to be 3 times 1. So we have 3 minus 1 in the brackets, that is 2. 2 squared is 4. 2 times 3 is 6, times 1 is 6. So what we are getting here is negative 2. So what is in the brackets is the same as negative 2 there. Okay. So how about 2 star negative 2? So what is in the bracket is now represented by the negative 2 there. So where we have a minus b, it's going to be 2 minus negative 2 squared minus, where we have minus 2ab, our a is 2, our b is negative 2. 2 minus negative 2, that is a 4. 4 squared is 16. Negative 2 times 2, it's minus 4. Minus 4 times negative 2, that is going to be positive 8. So we have plus 8. So 16 plus 8 is going to be 24. So 2 minus negative 2, that is a 4 squared 16. 2 times 2 times 2, that is going to be 8. Okay, so we have found 24. So what are we trying to say? So we are saying that 2 star 3 star 1, we are finding 24. So you can try out the other one as well. So in that case, we are starting with 2 star 3. So if you go to our equation there, okay, so if you go to our equation there, we have a minus b in the brackets. So our a is 2 in this case. So it's going to be 2 minus 3 squared minus our ab. It's going to be a product of 2 and 3. So 2 minus 3 in brackets, that is going to be negative 1, which is going to be 1. So negative 2 times 6 in the brackets here, it's going to be minus 12. Okay, so that is going to be negative 11. So in the brackets of negative 11. So negative 11 now is going to be start. It's going to be start with 1 there. So we now have negative 11 star 1. So we go to our brackets. We have a minus b. So it's negative 11 minus 1 squared minus 2. Our a is what? Negative 11. And our b is 1. So negative 11, negative 12. 12 squared is 144. Then minus 2 times 11. So that's going to be positive 22. So that is going to be 166. So what are we trying to say? So we're trying to say that for this part, 2 star 3, let me light that better. Okay, so the part where we're saying 2 star 3 star 1, what you're getting is 166. So now the question is, are these guys the same? They are not. So since they are different, we can say that the binary operation is not what? Okay, so I'm going to answer a question from 2022, Math 1120. So we have x star y is equal to 2x plus y squared. That's what we have. Where x and y are integers, of course. Show that the binary operation is, show that it is a binary operation on a set of integers. Of course, I already explained that. So if you multiply that integer by 2, it will still be an integer. If you square an integer, it will still be an integer. So you add integers, you still get an integer. So it is a binary operation. Now I'm more interested in commutativeness and associativeness. So what does commutative mean? So commutative means if you commute them or if you exchange them. Is it true that 2 plus 3 is equal to 3 plus 2? That's what commutativeness means. Now we avoid using numbers, we use letters. So we've been given x star y. So what if we say y star now x now? Is it also going to give you the same result? That's what commutativeness means. So we'll try that. So in this case now, just like we were substituting, it will be the same. So my x in this case becomes y, so it will be 2y, and now my x is y, so it will be x squared. So now the question that stands is, if you compare the two, what is on the right hand side, are they the same or they are different? So you can clearly see to the 2x plus y squared is not equal to 2y plus x squared. The result is definitely different. Very, very different. Okay? So we'll conclude to say, since x star y is not equal to the other one and the like, so x is not equal to, it is therefore not commutative. Therefore, binary operation is not commutative due to that very fact. Some of you are wondering, is it possible then to have it be commutative? Yes, of course. You can consider a case where you have this as a binary operation, x squared plus y squared. In such a case, even if you do try to exchange, you still have what? You still have the same result. It will be y squared plus x squared. Now you understand that if you compare these two, they are the same. Even if we've started with y squared plus x, the fact is they are the same because x squared is matching up, y squared is matching up. So the result is obviously going to be the same. So in such a case, we can say it's commutative. Now the cases that are strange is consider a case where you have something like a minus b and then squared. Let's say you have a star b. Is that commutative or not commutative as a binary operation? So if I would have to start now b star a, it will be b minus a squared. Now the question that you can ask yourself is it the same or they're different? Now this is where you'd have to be very careful. So consider a case where a and b were maybe 4 minus 2 squared and then 2 minus 4 squared. Is the result the same or they're different? They are basically the same, right? Now we want to prove using letters. So if you expand the top part there, you have a squared minus 2ab plus b squared. On the bottom you have b squared minus 2ab plus a squared. So you realize that they are basically one and the same. Wow. A squared is there, a squared is there. Negative 2ab is there, negative 2ab. B squared is there. So in this case, even if it looks different in the brackets, the result is basically the same. So this is commutative as well. Now let me go back to the question that was there in the exam, and then now answer the part for associativeness. So what does it mean when you say it is associative? So is this binary operation associative? So associativeness means, if you look at a binary operation and then you've got three numbers, consider a case where you have x star y and then you have star z. You've got three things there. Now is it true that even if you decide to start with, I'm sure we did under set theory, we talked about associativeness, we talked about three things. So if now I decided to start with y and z, would I get the same result? That's what associativeness means. So I'll start with the left hand side. Now notice that x star y has already been given, right? So that's what we've been given in the question. So now we just have to now find it against z. So I'll just say on my next step, x star y star z is equal to, so notice that this, what is in the brackets, has already been given. It is, that's why I decided just to pick up from x, y, z, because I know x, y has already been given. So if I look at that, that is basically what is the result was in there, right? And then my z is just z. So it tells me the first thing is matching up with x. The second part is matching up with y, which is now a z in this case. So where there's x, I'll put what is in the brackets, which is 2x plus y squared. That's why I have to be now smart. And then plus y squared. Y squared is representing what is on the right, which is z. So it will just be z squared. So we've simplified that. Going now on the next step, looking at the other side. The other side is now telling us to start with y star z. So of course, if you find y star z, it just tells you where there's x, put y. Where there's z, put what? Where there's y, put z. So because it's saying y star z, so that's what we're just trying to do there. Y star z. The answer will be 2y plus z squared. So on your last step now, where you're saying x star y star z. So y star z has already been found. The one that is showing on the top right corner there. Now it's telling us to start with x. So x is matching up with x. So I'll say 2x will be as it is. And then where there's y now, that's where we are putting y star z, which is 2y plus z squared, the power 2. Now if you compare these two, are they the same or they are different? Clearly you're able to see that there's a very big difference there. So since this is not true, it is not associative on the given binary operation. Okay, hopefully you now are okay with the idea of dealing with associativeness and commutativeness under this topic. Okay, so under a question under binary operations. So the operation star is actually on A and B, where it is equal to a squared plus 2b. So I'll write that. So a star b is equal to a squared plus 2b. So now the first part of the question is asking us to find -1 star 3. So how easy can we handle that? So it's just as simple as it is. A matches up with -1, b matches up with 3. So where there is a, we'll put -1. So -1 squared plus where there is b, we are putting a 3. So what is our result? So we have 1 plus 6, giving us 7. Then the other part of saying we'd have to find 3 star -1, which is equal to, so we have 3 squared plus 2, and then our b is -1. So plug in -1. So then we have 3 squared is a 9, and then 2 times -1 is a -2, giving us the answer of 7. So what are we trying to say? So the way binary operations work is make sure you're matching up. Whatever comes first, in this case it matters, okay? Because if you check A, it is A. So if you are given 3 to be A, where there's A, you put what? Your 3, as we can see. So we found in both cases, for both -1 and they are both giving us what? 7. Now, do we have to conclude from that point to say, since -1 star 3 and 3 star -1 are giving us 7, does it mean that it's commutative, or would have to go beyond that? So that's exactly why I came up with this question. So let's try to answer the question. Now the question was now asking us to determine whether the binary operation is commutative or not. Okay, so commutative talks about the aspect of it doesn't matter what you start with, you basically get the same result. Now we cannot base our solution on the same -1 star 3 and 3 star -1 just because they're giving us 7. So we'd have to use the equation itself. A star b is equal to a squared plus 2b. So now the question under discussion is it also going to give us the same result if we started with b? That's the aspect of commutativeness. So it will be now b squared plus 2a. So if you observe the right hand side, are these the same? Do you feel a squared plus 2b is equal to b squared plus 2a? They are obviously not the same. So that's why if you can try even others, you find that it will not work out. Okay, if you try different numbers other than 3 and -1, which gave us a 7. What if we decided to try maybe let's say 3 and 2? So if you try 3 and 2, for the first one, if you start with 3 and 2, you have 3 squared and 2. And then if you start with 2 and 3, is the answer the same? 3 squared is 9 plus 4, 13. One on the bottom, we've got 4. 4 plus 6, 10. So they're not the same actually. So it was only by coincidence that 3 star negative 1 and negative 1 star 3 were giving us 7. So never should you base your conclusion on the aspect of using numbers. Use the letters as they are given. So since this is true, since they are not equal, it's not commutative. Now the last part of the question was asking us to now determine whether it is associative or not. So we have a star b being equal to a squared plus 2b. So how do you find associativeness? How do you basically get to deal with it? So this is an aspect where now you have more than 3. So a star b in brackets and then let's say star c. For it to be associative, even a star b star c should also be the same. So of course I did explain earlier to say if you look at these, they tell you what you're supposed to start with. A binary operation is always supposed to start with 2 things. So looking at the first one, which is already a star b, and then we have a c. So notice that a star b has already been given. It is equal to that. Okay. So that's what we have. That is equal to a squared plus 2b. So we are now performing a binary operation against c. So this is now denoting, representing the first part a, and then our b is being denoted by c. So substitute in the equation. So where is a, we're going to put a squared plus 2b squared plus c. Where is b now, b is matching up with c. So we have 2c. Now we can now handle the other part, the right hand side, which is now a star b star c. Okay, so we need to find b star c since it's not given. So if we actually substitute b star c directly there, we're going to have b squared plus 2c. So that is what is denoting what? B star c. So substitute. So the first part is a, which is a itself, so it will just remain a squared. And then where there is b, now we are putting b star c, which is equal to b squared plus 2c. So the question at hand is, are these matching up? Are they the same? So clearly we can see that they are not basically the same. So since this is also not true, the binary operation is not associative.